So, what's the chance that another civilization, a twin civilization of ours, is transmitting radio signals exactly at the time that we are looking with our radio telescopes? In a world where space exploration has taken us to the Moon, Mars, and beyond, one of the most exciting endeavors in recent years has been the study of exoplanets, planets that orbit stars outside our solar system. Of these exoplanets, one stands out for its proximity to our own Sun, Proxima b. This Earth-sized planet orbits Proxima Centauri, the closest star to our solar system, making it an incredibly important object of study for astronomers. For years, scientists have speculated about the potential for Proxima b to harbor life, with its location within the habitable zone of its star suggesting that it might have liquid water on its surface. However, despite its close proximity, detailed images of Proxima b have remained elusive, with only distant blurry observations made through ground-based telescopes. That was until the Webb Space Telescope, the most advanced space observatory ever launched, made a groundbreaking achievement, a quantum breakthrough that revealed the clearest image of Proxima b ever captured. This breakthrough is not just a leap in our understanding of Proxima b, but a monumental milestone in the history of space exploration. The James Webb Space Telescope, or JWST, has been providing humanity with unprecedented views of distant galaxies, star-forming regions, and even exoplanets, but this latest discovery marks a dramatic step forward as it opens a new window into the study of exoplanets in ways we've never imagined. Let's dive into the specifics of this quantum breakthrough, the technology behind the Webb telescope, and what this new image of Proxima b reveals about our potential future in space exploration. What is Proxima b? Before we get into the breakthrough image captured by the JWST, it's important to understand why Proxima b is so significant. Proxima b is an exoplanet located just over 4 light-years away in the constellation Centaurus. It orbits Proxima Centauri, a red dwarf star that is part of a 3-star system known as Alpha Centauri. Proxima Centauri itself is the closest star to our Sun, which makes Proxima be the nearest known exoplanet that could potentially host life. Discovered in 2016 by astronomers using the European Southern Observatory's HRPS spectrograph, Proxima b has since been the subject of intense study. This planet is about 1.17 times the size of Earth, placing it firmly in the category of Earth-like exoplanets. But what really sets it apart is its position within the habitable zone of Proxima Centauri, also known as the Goldilocks zone. This is the region around a star where conditions are just right for liquid water to exist on the planet's surface, a crucial ingredient for life as we know it. Because of its proximity to Earth and its potential to harbor liquid water, Proxima b has become one of the most studied exoplanets in the search for extraterrestrial life. However, due to its distance from Earth and the glare of its host star, studying Proxima b in detail has been a challenge. That is, until the arrival of the JWST. The James Webb Space Telescope is a marvel of modern engineering, built to peer deeper into the universe than any of its predecessors. Launched on December 25, 2021, the JWST is designed to operate primarily in the infrared spectrum, allowing it to look further into space and capture the light emitted by the oldest and most distant objects in the universe. Unlike the Hubble Space Telescope, which observes primarily in visible and ultraviolet light, JWST is equipped with instruments that can see infrared light, wavelengths that are invisible to the human eye but incredibly important for studying things like exoplanets, star formation, and the earliest galaxies. The JWST's unprecedented ability to observe distant objects with clarity comes from its large 6.5-meter primary mirror, which is over twice the size of Hubble's mirror. This allows it to gather more light, resulting in clearer, more detailed images of distant celestial objects. Furthermore, the JWST is located at a position known as the second Lagrange point, or L2, about 1.5 million kilometers from Earth. This location is ideal for observing the universe without interference from the Earth's atmosphere or light pollution. The instruments on board JWST, such as the Near-Infrared Camera, NIR-CAM, and the Mid-Infrared Instrument, MIRI, allow it to observe exoplanets with unprecedented sensitivity. JWST can analyze the atmospheres of exoplanets, study their composition, and even detect the presence of water, methane, and other gases that are potential indicators of life. This is exactly what it has done with Proxima b. The quantum breakthrough in imaging Proxima b in unprecedented detail has been years in the making. Scientists have long been trying to get a better look at Proxima b, but despite their best efforts, the planet has remained a faint, blurry speck in the distance. Traditional ground-based telescopes have had difficulty observing such a distant planet, especially given the brightness of its host star, Proxima Centauri. Observing an exoplanet requires isolating the planet's light from that of its star, a tricky task that requires advanced technology and precise instrumentation. Enter the James Webb Space Telescope. Thanks to its powerful infrared capabilities and advanced techniques like coronagraphy, where a special mask is used to block out the light from a star, JWST has finally been able to capture an image of Proxima b that is far clearer than anything we've seen before. This quantum breakthrough represents a leap in our ability to study exoplanets. For the first time, scientists have been able to directly observe Proxima b in incredible detail. The image captured by JWST shows the planet with remarkable clarity, revealing key features about its size, composition, and potential habitability. The most important part of this breakthrough is that JWST was able to capture infrared light from Proxima b, which allowed astronomers to get a better sense of its atmosphere and surface conditions. The detailed image reveals faint atmospheric features that were previously hidden from view, as well as information about the planet's potential climate. One of the most exciting aspects of this quantum breakthrough is what the image reveals about Proxima b's atmosphere. Using JWST's infrared capabilities, scientists have been able to detect the presence of certain molecules in the planet's atmosphere. The most promising discovery is the potential presence of water vapor. Water vapor in the atmosphere of Proxima b suggests that the planet may have liquid water on its surface, a key ingredient for life as we know it. In addition to water vapor, the image also revealed traces of other gases such as carbon dioxide and methane. These gases are significant because they can be indicative of biological processes. On Earth, both methane and oxygen are produced by living organisms, so their presence in the atmosphere of Proxima b could be a sign that microbial life might exist on the planet. Of course, this is still speculative, and further study is needed to confirm whether Proxima b could truly harbor life. The discovery of Proxima b's clearest image and the potential signs of life is a huge step forward in the quest to explore exoplanets. However, we are still only scratching the surface of what the JWST and other future space missions will reveal about Proxima b and other exoplanets. In the coming years, astronomers will continue to study Proxima b in greater detail. One of the most exciting developments in the near future is the possibility of sending a probe to Proxima Centauri to study its planets up close. Although this is still many years away, advances in space technology, such as the development of ultra-fast propulsion systems, could make missions to our neighboring star system a reality. Proxima b could become one of the first exoplanets to be explored directly, providing us with invaluable information about what lies beyond our solar system. The quantum breakthrough in imaging Proxima b is a landmark moment in the history of space exploration. Thanks to the Webb Space Telescope, we now have the clearest image ever captured of this Earth-like exoplanet, along with crucial data about its atmosphere and potential for harboring life. This discovery is not only a major achievement for astronomers but a giant leap forward in our understanding of the universe. As we continue to study Proxima b and other exoplanets, we are entering a new era of exploration, one where the search for life beyond Earth is becoming a real possibility. The James Webb Space Telescope is our most powerful tool for uncovering the mysteries of distant worlds, and with each new discovery, we are one step closer to answering the biggest questions of all. What else is out there? Are we alone in the universe? The future of space exploration has never looked more exciting. Stay tuned, because the journey is just beginning. Beginning the importance of Proxima b in the search for life. When we talk about Proxima b and its significance in the search for extraterrestrial life, we're entering the realm of what is often considered one of the most exciting fields in modern astronomy, astrobiology. Proxima b's position in the habitable zone of its star, Proxima Centauri, makes it one of the most promising candidates for the existence of life beyond Earth. But what exactly does it mean for a planet to be in the habitable zone? The habitable zone, or Goldilocks zone, is the region around a star where the conditions are just right for liquid water to exist on the surface of a planet. This concept is based on the fact that life as we understand it depends on water. Water is not only essential for life's chemistry, but it also serves as a solvent for biological processes. Therefore, finding a planet with liquid water is one of the most important steps in determining whether life could exist there. Proxima b orbits its star at a distance where it is within this habitable zone, meaning that it could potentially have liquid water on its surface, depending on other factors such as its atmosphere and surface conditions. Its location within the habitable zone is one of the primary reasons why astronomers have been so interested in studying it. However, as with most exoplanets, there is a caveat. Proxima Centauri is a red dwarf star, which behaves quite differently from our Sun. Red dwarfs are much cooler than stars like the Sun and emit much less light, but they also tend to be more volatile, with frequent stellar flares that could strip away the atmosphere of a nearby planet. What makes Proxima b such a tantalizing target for the search for life is not just that it's in the habitable zone of its star, but that we now have the tools to analyze it in ways we never could before. The James Webb Space Telescope's unprecedented ability to observe exoplanets in detail has provided us with a clear picture of Proxima b's atmosphere, offering new insights into whether the planet could support life. The detection of water vapor, methane, and carbon dioxide in its atmosphere is an exciting development that could suggest the potential for biological processes. But even beyond these initial findings, the study of Proxima b raises fundamental questions about what it takes for life to arise on another planet. Is life more common in the universe than we think? Are there planets out there with life, but perhaps in forms vastly different from what we expect? Proxima b, with its Earth-like size and potential to harbor liquid water, serves as a valuable laboratory for testing these questions. Analyzing Proxima b's atmosphere, how JWST made the breakthrough, the groundbreaking image of Proxima b captured by the James Webb Space Telescope is not just a pretty picture, it's the result of sophisticated astronomical techniques that have allowed scientists to gain insight into the planet's atmosphere. But how exactly does JWST make these observations, and why is this new image so important? The key to understanding Proxima b's atmosphere lies in the ability to detect the planet's infrared radiation. When an exoplanet transits across the face of its host star, some of the star's light filters through the planet's atmosphere, and some of that light is absorbed by the molecules in the atmosphere. By observing this filtered light, scientists can determine the chemical composition of the atmosphere. This process is known as transmission spectroscopy, and it allows astronomers to detect the presence of various molecules such as water vapor, carbon dioxide, and methane. The JWST's powerful instruments are perfectly suited for this type of analysis. The telescope's near-infrared camera, NIR-CAM, and mid-infrared instrument, MIRI, allow it to observe the exoplanet's atmosphere in incredible detail. These instruments can capture wavelengths of light that are not visible to the human eye, revealing key information about the composition and structure of the atmosphere. JWST's coronagraphs also allow it to block out the light from Proxima Centauri, allowing the planet itself to be more clearly observed. In the case of Proxima b, the Webb telescope was able to analyze the absorption patterns of light that pass through the planet's atmosphere, revealing important molecular signatures. The detection of water vapor, methane, and carbon dioxide, molecules that are often associated with biological processes, could suggest the possibility of life. Of course, this doesn't mean we found life on Proxima b yet, but it certainly makes the planet one of the most promising candidates for further study in the search for extraterrestrial life. Moreover, the JWST observations have also provided us with more information about the planet's surface conditions. The image revealed that Proxima b's atmosphere may be in a dynamic state, with weather systems or other environmental factors at play. By analyzing these features, astronomers can begin to understand how the planet's atmosphere behaves over time, which is crucial for determining its habitability. Comparing Proxima b to other Earth-like exoplanets, the discovery of Proxima b's Clearest image is exciting not only because of what it tells us about this particular exoplanet, but also because of how it fits into the broader picture of exoplanet research. Proxima b is not the only Earth-like planet out there. Astronomers have discovered thousands of exoplanets in the last few decades, many of which are located in the habitable zones of their stars. However, Proxima b holds a special place in the study of exoplanets due to its proximity to Earth. In fact, Proxima b is one of the closest potentially habitable planets to Earth. Its proximity means that it is one of the most accessible targets for study, making it a prime candidate for further observation by telescopes like the James Webb Space Telescope. As JWST continues to observe Proxima b, scientists will be able to gather more data about its atmosphere, surface conditions, and potential for life. But how does Proxima b compare to other Earth-like exoplanets? In recent years, astronomers have discovered planets such as Kepler 452b, TRAPPIST-1d, and LHS 1140b, which are also located in the habitable zones of their stars. Some of these planets are even similar in size to Earth, making them candidates for the search for life. However, Proxima b has some unique characteristics that set it apart from these other exoplanets. For one, it is part of the Alpha Centauri star system, the closest star system to our own. This proximity means that Proxima b is a prime target for future space missions and may even be one of the first exoplanets that we send probes to in the future. Furthermore, the fact that it orbits a red dwarf star rather than a sun-like star presents unique challenges and opportunities for studying its atmosphere and potential for life. Red dwarfs are known for their variability, which can have significant impacts on the habitability of nearby planets. Understanding how Proxima b responds to these stellar flares and how it might protect its atmosphere is a critical part of studying its potential to support life. The role of quantum physics in the study of exoplanets. At the heart of the JWST's groundbreaking discoveries lies a principle of quantum physics, the behavior of light. Quantum physics plays an essential role in our understanding of the universe, and it is the basis for many of the technologies that allow us to study distant worlds like Proxima b. When light passes through the atmosphere of a planet, it interacts with the molecules present, and this interaction is governed by the principles of quantum mechanics. In quantum mechanics, particles like photons, light particles, and molecules behave in ways that can seem counterintuitive to our everyday understanding. For example, light can behave as both a particle and a wave, and molecules can exist in multiple states simultaneously before being measured. These strange behaviors are essential to understanding the absorption patterns that scientists use to study exoplanet atmospheres. The JWST's ability to detect the subtle interactions between light and matter is made possible by a deep understanding of quantum mechanics. By applying quantum principles to the study of light and matter, astronomers can unravel the complex puzzle of an exoplanet's atmosphere. This quantum breakthrough allows us to capture images of exoplanets like Proxima b with a level of clarity and detail that was once unimaginable.